Methods of preparing salts. Now, this is all very wordy. These are the kind of things that you really need to do rather than read about and see in pictures. Okay, so in class, hopefully you'll get a chance to make some of these salts and use these methods and understand their real significance. Right, so we're going to kind of slip through this fairly quickly, but you do need to know the outline of the procedure of how to prepare different salts using slightly different methods. Okay? Acid plus something is almost always going to give you a salt, isn't it? You know the four equations that we've looked at already. So the first one we're going to look at is acid plus metal. Now, again, these are practical considerations you must take into account using your experimental techniques that you studied at the beginning of year 10. So what we would do is we would add an excess of the metal to the acid and we would stir until all of the effervescence stops. Why? Because then we know that all of the acid has been used up. We don't want any acid to be left in our salt. We would then filter the excess metal off. Obviously the excess metal stays as the residue and the filtrate is in the evaporating basin underneath. We can filter directly into an evaporating basin because the next step is that we evaporate off about half the volume of the water until the crystallization point is reached. Now the crystallization point is when we know that if the solution cools, crystals will start to form. And the way to test this is to stick a glass rod into the solution and then take it out and let it cool, and you'll see that solid forms on the surface of the glass rod. So as the solution cools on the glass rod, crystals are formed. You can also see sometimes a ring of solid around the inside of the crystallization dish, the evaporating basin, we call it. Once that's happened, then we can say, right, let's let the solution cool. So we let the evaporating basin cool down. And what will happen is crystals will start to form almost immediately. Now, if we want those crystals quickly, we can then filter the mixture again. The crystals stay in the filter paper, and then we can dry the crystals using other filter paper or in an oven at a low temperature, not a high temperature, because it could potentially cause the crystals to thermally decompose. So at a relatively low temperature just to dry them, and then you've got a sample of your crystals, you've got your salt. This method is not suitable if the metal is very reactive, such as potassium or sodium, or if the metal is unreactive. It won't react with an acid, for example, copper or silver. Next one, acid plus insoluble base, typically a metal oxide. So a similar kind of process, we add an excess of the base to warm acid this time because this reaction is quite slow at room temperature. We stir it and we keep adding the base until no more base dissolves. So we'll see the solid floating or sinking, but we'll see the solid present in the solution or in the liquid mixture. Then we filter off the excess base, we collect the filtrate in an evaporating basin, and then we follow the same procedure as before, as you can see. Acid plus carbonate. Carbonates tend to react with acids at room temperature, so we add the excess of the carbonate to the acid and we stir until the effervescence stops. Again, you'll be able to see the carbonate floating around in the mixture. We filter, collect the filtrate, and then the same procedure as before. Remember, we're adding excess carbonate because we want to use up the acid. Now, acid plus alkali is a bit more complicated, simply because you can't actually see the product, and it's very difficult to know when you've added enough of the acid or the alkali. So what we do is we use a titration. So we titrate a small amount of the acid, for example 25 centimeter cubed, with alkali from a burette, and we use PP. PP is phenolphthalein. Then we get the end point, so we get the point where the acid has just been neutralized by the alkali, and we look at the burette and we know how much of the alkali we added. Let's say we added 27.5 centimeter cubed. Then what we do is we do the same procedure again, but we don't add the alkali this time. So we repeat the titration and we add 25 centimeter cubed of the acid to the conical flask, and then we would add, like I said before, 27.5 centimeter cubed of the alkali, but no indicator. But we know that alkali has just neutralized the acid. So in that mixture now, you've got water and you've got the salt. And then the same procedure is followed. You evaporate off about half the volume until the CP is reached, and then you allow the solution to cool and crystals to form. Okay, and you can filter and dry them if you wanted them straight away. Right, they're the four basic methods of acid plus another substance to produce a salt. Remember, we are preparing salts. Okay, so let's look at some specific examples of some of the methods on the previous slide. So here we have acid plus metal. Well, this is a good opportunity for you to start to practice writing these equations and balancing the equations. Now remember, in some cases they will give you in a question the starting materials and you'll have to work out what they produce. But they might give you the final salt and say, what would you need to use to make this salt? So you have to be able to work both ways. So write the equation for zinc and nitric acid. You can pause the video here while you do it, and then you can check. Okay, well there's the basic formulae of everything present. Zinc metal is a solid. Nitric acid is obviously aqueous. Zinc nitrate is soluble. All nitrates are soluble, and we'll come to that soon. And hydrogen gas is produced. You will notice that this doesn't balance. There are two hydrogens here and only one here. There are two nitrates here and only one here. So yes, the simple solution to that is to put a 2 in front of your nitric acid, and now it balances. Right, let's try acid plus insoluble base. Typically a metal oxide. So there you go, iron 3 oxide and hydrochloric acid. Try that. Stop the video and try and write the equation and balance it. Remember, get the formulae correct before you try and balance. Right, there's the basic formulae of the chemicals present. Iron 3 oxide obviously has got Fe3 plus ions, so you need 2 Fe3 plus. Oxides are 2 minus, so you need 3 2 minuses. Okay, and iron 3 chloride is produced. Great. Now, balancing here could be quite tricky. There are 2 ions here, so let's start somewhere. 1 iron here, so let's put a 2 in front of that, so now the ions are balanced. 2 times 3, 6 chlorides here, so we need to put a 6 in front of that to get 6 chlorides. Now we've got 6 hydrogens, which is going to make 3 waters, isn't it? And let's just double check the oxygens. 3 O's, O3, so the oxygens work. This is good practice. Acid plus carbonate. So calcium carbonate and sulfuric acid. Obviously, calcium sulfate is going to be produced. Remember, here with nitric acid, we had nitrates produced. With hydrochloric acid, we've got chlorides. And with sulfuric acid, we get sulfate. So calcium sulfate. Have a go at the equation. Okay, there's the basic formulae. Sulfuric acid and calcium carbonate. all the formulae are correct. So what balances, what doesn't balance? Have a go, look through that. Is there anything that needs balancing? And the answer is no. An acid plus alkali, classic hydrochloric acid and sodium hydroxide. That's really easy to write, isn't it? It's a 1-to-1 mole ratio. We would do this kind of thing in a titration. So this is where, as you saw on the previous slide, you would need the indicator the first time and then do it again with the same volumes of the different solutions, but without the indicator to ensure neutralization. And obviously hydrochloric acid, sodium hydroxide are going to produce sodium chloride. Okay, there's some really simple examples of what you saw previously, but you need to be able to do this. And remember, you need to be able to predict the salt that's going to be made from particular reactants and to predict the reactants required to make a particular salt. Right, read the pages and answer the questions.